Welcome back to G Fun Facts Online. Today we are stripping away the myths of the Giza Plateau to look at the hard science of the most significant archaeological discovery of the 21st century. For 45 centuries, the desert wind has scoured the limestone casing of the Great Pyramid, and for most of that time we believed the map of the interior was complete. We thought we knew every corridor, every chamber, and every shaft. We were wrong. As we stand in the early months of 2026, the world of Egyptology is holding its collective breath. Dr. Zahi Hawass has announced a major revelation to be unveiled this year, a discovery that was not made with dynamite or pickaxes, but with shadows from the stars. We are talking about the Khufu Void, a massive, plane-sized cavity suspended in the heart of the pyramid, completely isolated from all known corridors. Today, we are going to break down exactly how this void was found using particle physics, the competing theories of what it actually is, and the high-stakes mission currently unfolding to breach this final sanctuary of the 4th dynasty. To understand the magnitude of this discovery, we have to start with the ghostly messengers that revealed it. The Great Pyramid is a fortress of 2.3 million stone blocks. It is a structure so dense that it defies standard X-rays or ground-penetrating radar beyond a few meters. To see inside a mountain of limestone, scientists had to rely on a source of radiation that originates not from a machine, but from the cosmos itself. Every second, the Earth is bombarded by high-energy primary cosmic rays. These are protons and atomic nuclei stripped of their electrons, traveling across the galaxy at nearly the speed of light. When these particles smash into the upper atmosphere, they trigger a cascade of secondary particles. Among these is the muon. You can think of muons as the heavy cousins of electrons. They are unstable, existing for only 2.2 microseconds before decaying, yet they travel so fast that relativistic time dilation allows them to reach the Earth's surface. They rain down on us constantly. As you listen to this, roughly 100 muons have passed through your body. Crucially for archaeologists, muons behave like high-energy X-rays. They can pass through hundreds of meters of solid rock, but they are slowly absorbed as they do so. The denser the material, or the longer the path, the fewer muons make it through. By placing a detector beneath or beside a massive object like a pyramid, scientists can count the muons arriving from different directions. If the pyramid were solid rock, the muon count should be uniform based on the thickness of the stone. But if there is a hole, a void, more muons will pass through than expected. The shadow of the pyramid will appear lighter in that specific spot. In October 2015, the ScanPyramids mission was launched to exploit this physics. This was a collaboration between the Egyptian Ministry of Antiquities, the Faculty of Engineering at Cairo University, and the HIP Institute from France, joined by particle physicists from Nagoya University and KEK in Japan, and CEA in France. Their goal was not to dig, but to look. They deployed 3 distinct muon detection technologies to ensure that any anomaly found was real and not a glitch. They placed nuclear emulsion plates, which are essentially high-tech photographic films, inside the Queen's chamber. Like developing a long-exposure photograph, these plates sat in the dark for months, catching muons raining down through the pyramid's core. They also used scintillator hodoscopes, electronic detectors that flash with light when a muon hits them, offering real-time data. Finally, they placed micromegas gas detectors outside the pyramid to look for cavities near the surface. For 2 years, the team collected data. The results, published in the journal Nature in November 2017, sent shockwaves through the scientific community. The detectors in the Queen's chamber had found a significant excess of muons coming from a region directly above the Grand Gallery. They called it the ScanPyramids' Big Void. This was not a small crack or a few missing stones. It was a massive cavity, at least 30 meters or 98 feet long. It has a cross-section similar to the Grand Gallery itself. It was the first major internal structure found in the Great Pyramid since the 19th century. So what do we know about the anatomy of this ghost in the machine? The Big Void hovers roughly 40 to 50 meters above the Queen's chamber. It is situated almost directly above the Grand Gallery. The muon data indicates a length of at least 30 meters. Its height and width are less certain, but appear to rival the Grand Gallery, which is over 8 meters high. Initially, it was thought to be horizontal, but newer analyses suggest it might be inclined, mirroring the slope of the Grand Gallery below it. This detail is crucial for the internal ramp theories we will discuss shortly. Most importantly, it is isolated. There are no known corridors connecting to it. It appears to be completely sealed, a time capsule untouched since Khufu's funeral barge was dismantled. Now, skepticism is a healthy part of science. When the discovery was announced in 2017, Zahi Hawass was initially dismissive, suggesting the data might just be showing gaps between irregular core masonry. He cautioned against using the word discovery until a physical entrance was found. But the physics held up. The probability of the muon excess being a statistical error was less than 1 in a million. The void was there. Then, in 2023, came the breakthrough that silenced the doubters. While the Big Void grabbed headlines, the ScanPyramids team was quietly investigating a second anomaly on the north face of the pyramid, just above the original entrance. There's a massive chevron structure there, 4 huge limestone blocks leaning against each other. For centuries, Egyptologists assumed this was merely a structural arch. The muons disagreed. They showed a small void directly behind the chevrons. In early 2023, the team realized that a small joint between the chevron blocks was just wide enough, mere millimeters, to insert a borescope. On March 2, 2023, the world saw the first images from inside the ScanPyramids north face corridor. The endoscopic camera revealed a rectangular passage with a gabled, triangular ceiling. It was roughly 9 meters long, 2 meters wide, and over 2 meters high. It was empty. The floor was rough blocks, not polished paving. The ceiling was a saddle vault of limestone beams. Crucially, the corridor didn't go anywhere. It ended in a solid wall of limestone. This discovery changed everything because it validated the technology. It proved the muon detectors were accurate to within centimeters. If the muons said there was a corridor behind the chevrons, and we found one, then the muons saying there is a massive void above the Grand Gallery must be trusted. This north face corridor also provided architectural clues. The gabled ceiling is identical to the ceiling of the Queen's Chamber and the stress-relieving chambers above the King's Chamber, suggesting a weight distribution function. Zahi Hawass reversed his earlier skepticism and seized on this discovery. He speculated that this corridor might be protecting something beneath it, stating, "I believe that the burial chamber of King Khufu was not found yet." He hypothesized that the true burial chamber could be hidden behind the solid wall at the end of this corridor. But if the north face corridor is the appetizer, the Big Void is the feast. What function could a 30-meter-long hall serve in the heart of the pyramid? Let's look at the theories. Theory A is that it is a relieving chamber. The Great Pyramid weighs 6 million tons. The internal pressures are immense. The King's Chamber is protected by 5 layers of massive granite beams and a gabled limestone roof to divert the weight. Some engineers argue that the Big Void is simply a construction gap designed to protect the Grand Gallery from collapsing under the weight of the masonry above it. However, the counter-argument is strong. The Grand Gallery is built with corbelling specifically to support weight and has stood for 400–500 years without cracking. Why build a second massive gallery above it just to protect the first? It seems like structural overkill. Furthermore, relieving chambers are usually directly above the room they protect, whereas the Big Void is separated by a significant layer of rock. This leads us to Theory B, the internal ramp, championed by French architect Jean-Pierre Houdin. Houdin has spent decades arguing that the Great Pyramid was built from the inside out using an internal spiral ramp. He proposed this long before the ScanPyramids data existed. According to Houdin, the bottom third of the pyramid was built using an external ramp, but the top 2/3 required an internal tunnel spiraling up behind the outer casing. He also theorized a counterweight system used to haul the massive 60-ton granite beams of the King's Chamber. This system would require a long sliding track, essentially a second Grand Gallery, where a counterweight could move up and down. The dimensions of the Big Void fit Houdin's counterweight slide theory perfectly. If the void is inclined, it supports this hypothesis even more. It could be the fossilized remains of the construction engine itself. Theory C is the most exciting for the public, the real burial chamber. The King's Chamber we know contains a red granite sarcophagus that is roughly finished and has no lid. No mummy was ever found. Khufu's father, Sneferu, built 3 pyramids, and the Red Pyramid has a burial chamber located high up in the structure. Some Egyptologists speculate that the King's Chamber was a decoy, or a statue chamber, and the true burial took place in a hidden suite of rooms. The Big Void is large enough to be a grand gallery leading to a final, higher sanctuary. There are oddities in the pyramid, like the unfinished subterranean chamber, that suggest changes in plan. If Khufu feared tomb robbers, he might have engineered the ultimate misdirection. Finally, Theory D suggests a religious function, representing the primal mound or island of creation. The void could be a deliberate nothingness incorporated into the design, a pocket of chaos sealed inside the order of the stone. While poetic, this is difficult to prove archaeologically. This brings us to the present, and the mission scheduled for 2026. In late 2025, Dr. Zahi Hawass, speaking at the Sharjah International Book Fair, dropped the bombshell announcement that a new mission was underway. This phase involves the original ScanPyramid scientists and a new wave of explorers, with American businessman Matt Beal linked to the funding. The 2026 mission is not just about more muons, it is about access. We cannot simply drill a large hole through 40 meters of limestone. That would violate the core tenets of conservation. Instead, the plan relies on a multi-stage approach. First, precision muography. New, ultra-sensitive detectors have been placed in the Grand Gallery and the relieving chambers to map the exact boundaries of the void to within a few centimeters, creating a 3D digital twin. Second, micro-robotics. The team is developing a new class of exploration robots. Unlike the Jedi robot that explored the Queen's chamber shafts in 2011, these new bots are designed to fit through boreholes less than an inch wide. The rumored plan involves drilling a microhole from the relieving chambers, or the top of the Grand Gallery wall. A fiber optic snake robot would be inserted. This robot is equipped with LiDAR to map the interior of the void instantly, and spectrographic sensors to smell the air, looking for organic decay, incense, or cedar wood. Consider the stakes. If the camera enters the big void and sees rough blocks, it validates the construction gap theory. Interesting for engineers, but perhaps disappointing for the public. If it sees a sloped track with traces of grease or wood, it validates Houdan's internal ramp theory, which would be a triumph for engineering history. But if it sees polished walls and hieroglyphs, it changes history. It would be the first intact royal chamber found in the Great Pyramid. Even a sealed door would mean the mystery continues. To understand why this is so electrifying, we must look at the history of those who tried to crack Khufu's safe before. In 820 AD, the Caliph al-Ma'mun instructed his men to batter their way into the pyramid using fire and vinegar. They bypassed the true entrance and tunneled blindly until they hit the descending passage, finding the king's chamber empty. In 1837, Howard Vyse, the gunpowder archaeologist, used dynamite to blast his way into the relieving chambers, where he found the graffiti naming Khufu. In the modern era, we move to robots. In 1993, Rudolf Gantenbrink sent the Upuat rover up the southern shaft, hitting a limestone door with copper handles. In 2002, Zahi Hawass drilled through that door on live TV, only to find another door behind it. The Big Void is the culmination of this lineage. We have moved from battering rams to dynamite to robots to cosmic rays. And what of Khufu himself, the man behind the mountain? We have only one distinct portrait of him, a tiny 3-inch ivory statue found at Abydos. His face is calm and confident. While Herodotus called him a tyrant, modern archaeology at the lost city of the pyramid builders suggests his workforce was well-fed and organized, likely paying their tax in labor rather than serving as slaves. If the Big Void contains Khufu's true burial, it could answer the question of his character. Would the tomb be filled with gold, like Tutankhamun's? Or would it be austere, reflecting the solar theology where the king's soul ascended to become a star? As we await the 2026 revelation, it is worth pausing to appreciate the sheer audacity of the Great Pyramid's construction. It is aligned to true north with an accuracy of 3/60ths of a degree. It contains blocks weighing up to 80 tons. If the Big Void is a construction feature, it reveals that the architects, led by Khufu's vizier Hemiunu, anticipated the internal stresses of the structure 20 years in advance. The ScanPyramids data has even revealed thermal anomalies on the surface, suggesting the pyramid breathes with airflow from deep within. In conclusion, we stand on the precipice of discovery. The ScanPyramids project has done something thought impossible. It found a new room in the most studied building on Earth without lifting a single stone. The Khufu Void is more than just empty space. It is a vessel for our curiosity. In 2026, when the light of a fiber optic cable finally pierces that darkness, we will not just be looking into a room. We will be looking into the mind of the architect who built it. We will be looking into the ambition of a king who wanted to conquer death. Whether it is a tomb, a machine, or a mistake, the Void reminds us that the past is not dead. It is waiting. And thanks to the silent rain of cosmic muons, we have finally found the key.